Section 8.3 is going to be split into a couple of days, but the title of the section is Representing Linear Functions. So by the end of this lesson, you will be able to solve linear equations with two variables, and you will also be able to graph linear equations using ordered pairs. First, let's talk about a couple of vocabulary terms. A linear equation is simply an equation whose graph is a line. So think linear and line. It's going to be a straight line. It is a function because each number in the domain is paired with exactly one number in the range. There are no x values that will repeat in a linear equation. A solution to a linear equation consists of two numbers and one for each variable. So an x and a y, or an ordered pair, that make the equation true. Please make sure you have both of these definitions written down. So let's look at some examples where we're asked to find solutions to the linear equation. It's easiest, I think, in the beginning to write out a chart like this. So if you could, please copy the chart down. Notice I have 4 rows for the 4 solutions. When you're asked to find solutions to a linear equation, we get to pick the x values. Remember, the x is the input. And we want to pick values that aren't going to be too difficult, especially if we have the choice. So for example, we could pick 0, 1, 2, and 3. What we want to do then is plug those values in for x. So we get y equals 7 times 0. Y is going to equal 7 times 1, 7 times 2, and 7 times 3. So what do we get for y? 7 times 0 is 0, 7 times 1 is 7, 7 times 2 is 14, and 7 times 3 is 21. So our ordered pairs are 0, 0, 1, 7, 2, 14, and 3, 21. These are the solutions. When you're asked to write the solution as an ordered pair, it should look like this column here. So again, you're asked to find the solution. You pick the inputs, plug them into the equation, find out what y equals, and then write the answer as an ordered pair. Example 2, we have 4 solutions of y equals x plus 2. So again, we get to pick the values for x. I'm going to pick a couple negative values sometimes. That doesn't hurt either. So -2, -1, 0, and 1. So again, we're plugging those values in for x. -2 plus 2. -1 plus 2. 0 plus 2. And 1 plus 2. And then in order to find y, we just need to compute. So -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. And 1 plus 2 is 3. So our ordered pairs, and remember ordered pairs are in the order x first, then y. We have -2, 0. -1, 1. 0, 2. And 1, 3. So those are the 4 solutions to the linear equation. I'd like you to pause the video here, try to find 4 solutions on your own, and then check your work with me. And in order to check, let's make sure we all do the same ordered pairs. Let's do -1, 0, 1, and 2. So please use these for your x. Pause the video and try to find the solutions. So first we have -4 times -1 minus 6. If we plug in a 0, it's -4 times 0 minus 6 If we plug in a 1, negative 4 times 1 minus 6. And if we plug in a 2, it's negative 4 times 2 minus 6. So now we need to compute to figure out what the output is of the function. Negative 4 times negative 1 is positive 4. Positive 4 minus 6 is a negative 2. Negative 4 times 0 is 0. 0 minus 6 is negative 6. Negative 4 times 1 is negative 4. Negative 4 minus 6 is negative 10. Negative 4 times 2 is negative 8. Minus 6 is negative 14. So our ordered pairs are negative 1, negative 2, 0, negative 6, 1, negative 10, and 2, negative 14. Hopefully you did get all 4 of those solutions, and if not, you can see where you went wrong. With this subtraction of 6, if you want to change that to adding the opposite, you're always more than welcome to do that. Now let's look at some graphing. We can also graph linear equations, and the first way that we'll talk about today, how to graph linear equations, is using that same chart that we just created, where we pick a series of inputs and then graph them based on the output. The rule will be, for this class, you must have 4 ordered pairs. So you need 4 ordered pairs to graph the line. Now you technically only need 2 to draw a line, but I want 4 ordered pairs on the graph. Now you may notice that the first equation we've chosen, y equals 7x, is from example 1. So instead of us recreating and making a new table, let's use the solutions we had from number 1. So I need to go back to number 1, and I want to copy down these solutions to number 4. So the ordered pairs we found were 0, 0, 1, 7, 2, 14, and 3, 21. Remember, the title of this lesson is linear, which means everything that we graph should be a straight line. If you start graphing and your graph is not a straight line, you have an error somewhere in one of your solutions. So first we graph 0, 0. That's the origin. Next we want to graph 1, 7. So I'm going to go to the right 1 and up 7. Next we have 2, 14, and you're going to see that that's already going to go off our graph, but I'm going to go ahead and put it on there. 2, if this is 10, 11, 12, 13, 14. It's kind of in that R there. Now I definitely don't have enough room to put in 321, but I still need to find a 4th ordered pair. So what I'm going to use is negative 1. What happens if we plug in a negative 1 for x? We get negative 7. So here's a 5th ordered pair. We're going to use this one to graph though. So negative 1, negative 7 is down here. And now you can see our line through the ordered pairs that we've graphed using solutions or by making a table. Sometimes, or some of you may have recognized this idea as plugging in a 0, output is a 0. Plugging in a 1, output is a 7. Plugging in a 2, output is 14. Plugging in 3, output is 21. And plugging in that negative 1 gave us negative 7. So there's lots of different ways to represent these solutions. I used a pretty fancy table in the beginning so you could see where we were plugging values into, and then we wrote our ordered pairs in the last column. You can just make a table like this. So let's look at another example. Graph y equals x plus 2. Again, this is example 2, so we can copy some of those ordered pairs and not have to recompute everything. So let's go back to example 2 and look at the ordered pairs. These are the 4 solutions that we found: negative 2, 0, negative 1, 1, 0, 2, and 1, 3. So we're going to rewrite those back on example 5. And we'll use these ordered pairs to graph. And I'm going to go ahead and write them in a chart form here. We have negative 2, 0, negative 1, 1, 0, 2, and 1, 3. Now I know you don't have graphs in your notebook, but you can draw a pretty nice graph just using the lines on your paper. So first we graph negative 2, 0. That's to the left 2, and we don't go up at all. And then we have negative 1, 1. We have 0, 2. And we have 1, 3. So you can see these ordered pairs do make a line. We've got 4. And I like to extend the line all the way across the graph. Please make sure you're putting arrows on both ends of the line, since it is a line and not a segment. And you do need to be graphing these. I will be checking for graphs when I check your notes. The final example is example 6. We're asked to graph y equals 3x minus 9. This isn't an example that we've done yet, so we're going to talk about how to pick some values that will give us good ordered pairs to graph. So I'm going to make a t-chart. I won't make a table that was as fancy in the beginning. And I'm going to plug in, let's do 0, 1, 2, and 3. So when we plug in a 0, remember you're plugging it in for x. It's your input. 3 times 0 is 0. But then we have to subtract 9. So that gives us negative 9. If we plug in a 1, 3 times 1 is 3, minus 9 is negative 6. Plugging in a 2, 3 times 2 is 6, minus 9 is negative 3. And plugging in a 3, 3 times 3 is 9, minus 9 is 0. So there are the 4 ordered pairs that I want you to use to graph. First we have 0, negative 9. That's way down here on the y-axis. Then we have 1, negative 6. 2, negative 3. And 3, 0. You can see that our ordered pairs do make a line. And so we're going to draw our line through those ordered pairs, extending it through the graph and drawing arrows on both sides. Let's say though, just for real quick, let's say if you plugged in a 3, you got a number like 7. So you're plugging in 3 and you're going up to 7. You can tell that that ordered pair doesn't fit on our line. So there's probably been some sort of error here in your computing, and you need to go back, plug the 3 back in, and find the correct answer. So it's easy to tell sometimes when our lines or when our ordered pairs or our solutions are incorrect because they don't fit on our line. But that's what your line should look like for the graph of the linear equation in number 6. So if we go back to our objectives, could we solve linear equations with 2 variables? Those are the first 3 examples where we selected an input, found the output, and then wrote the answers as ordered pairs. Also, were we able to graph linear equations using ordered pairs? Those were the final 3 examples where we were graphing using the t-table or t-chart, selecting our own input, plugging in, finding the output, and then graphing. In class, we'll work on worksheet 8.3a.